Work out the exact value of x. When dealing with indices, we must have the same base. In this case here, I can realise I can rewrite 16, 2 and 8 as all having a common base of 2. Therefore 16 as a base of 2 is 2 to the power 4. So in brackets 2 to the power 4, and it will still raise to the power of 1/5. It's still multiplied by, this is already a base of 2, so I'm going to keep the base the same as 2 raised to the power x. And on the right hand side, I can realise I can rewrite 8 as a base of 2 as being 2 to the power 3, as 2 cubed is 8. And that's still raised to the power 3/4. Applying our laws of indices now, when we've got a power raised to power, we know we keep the base the same and we multiply our powers. In this case, 4 times a fifth will give us 4/5. We're still multiplying by 2 to the power x. And on the right hand side, again, if we've got a power raised to power, we know we keep the base the same, in this case 2. And a power raised to power, we multiply our powers, in this case 3 multiplied by 3/4 will give us 9/4. When multiplying and we've got the same base, in this case we've got a base of 2, we keep the base the same and we add our powers. So here I've got 4/5 plus single x, and that's going to equal to, on my right hand side, I've still got 2 to the power of 9/4. Now that I've got a common base, the same base on both sides, I've got a base of 2, therefore I can just equate the powers. So therefore it's going to have a linear equation, and therefore I'm going to have 4/5 plus x is going to equal to 9/4. As I'm solving for x, I want to get x by itself. I know the opposite of add 4/5 is to subtract 4/5 from both sides. If I subtract 4/5 from both sides, on the left-hand side, I know 4/5 subtract 4/5 will cancel. That will leave us with x, exactly what I wanted. On the right-hand side, 9/4 subtract 4/5 gives us 1.45 as a decimal.